Hello. Okay, so a few weeks ago, video popped into my feed. Title was completely misleading, so I watched it, and it was basically questioning whether or not we've actually got people in space, or whether that's all a big conspiracy. Now, a lot of money to be made on this, so I can see why people would think yes, this is someone faking it all so they can spend money another way. But at the same time, I'm not going to say yes. I do believe that we, you know, I believe we've been in space. Now, I am willing to look into it and see whether or not, but that's not the point of this. So the point is, they were what it was. It was someone reviewing other people's videos, questioning it. So this, I'm responding to someone's response to someone else's video. And I will point out one thing that they did say: it's easy to fake a video. And they showed, a guy in his backyard with this glob of water floating around like it was in outer space, saying, "Look, I made this in my backyard. It's easy to fake a video." That said, how do we know that none of these videos claiming to be debunking that we were in space were faked by someone? I did look up some official space station videos a few days later, and so I couldn't really compare the backgrounds and say yes, this is the same set, so therefore they are possibly the same, because didn't have the link to the original video I saw. But one thing I did notice, the one thing that stood out most, was the women in the debunked video, or the original video I saw, let's call it. Their hair was standing straight up, and it looked like it was lacquered in place, or shellacked, or whatever. That wouldn't happen. And so that's one thing I started looking for. When I looked at the NASA videos, was look for videos with women and what's their hair doing. Because one thing I think a lot of people don't get is the difference between inertia and gravity. A lot of people treat them like they're the same. Gravity affects inertia, but it's not the same. It's not the only thing that affects inertia. So that's what I'm going to talk about today: is gravity versus inertia. And I'm going to, in part, review, go back to these videos I've been watching about the space station. Now, like I said, how do we know that the videos that the guys were saying this proves that we've never been to space weren't made in someone's backyard? How do we prove that the NASA videos weren't made in someone's backyard? I'm not going to get into that stuff. I'm going to stick more specifically with inertia versus gravity. I'm not going to come to a conclusion about whether we've been in space or not. I'm just going to use it as an example to show how some people don't understand the difference between inertia and gravity. And there's one other point I wanted to make. See if I can think of it off the top of my head. Hopefully I'll think of it later. Okay, so Newton's first law. Most people call it the law of inertia, which I don't like. It is about inertia. I don't like the term inertia because inertia, you think inert. And when you think inert, you think not in motion. And no, inertia does, things in motion do have inertia too. So that's the only thing I don't like about it. But more accurately, it was just a rephrasing of the conservation of momentum. An object in motion will stay in motion until acted upon by an outside force. An object at rest will stay at rest until acted on by an outside force. And what do we mean by emotion? My hand's in motion, so this will keep up until actually it's doing this because I'm putting forces on it. When we're talking about in motion, we mean constant direction, constant velocity or speed. Yeah, being redundant when I say direction and velocity in the same sentence. And that means basically conservation of momentum. Because that's the one thing Newton did mention in his works, was that if the mass changes, that's going to change momentum. That's also going to be have the effect of a force on the object. And we don't discuss that in high school. In college, we did, and we actually did some calculations for stuff like you got a rocket and it's burning fuel, so its mass is changing, or rather, it's giving off mass in the form of exhaust of some sort. So we did some calculations with that, just show that everything we learned about Newton's laws was actually not incorrect, just poorly phrased when we did it earlier. Because Newton actually wrote his laws in terms of momentum as opposed to in terms of force, or more in terms of momentum than we learned in high school. That's a better way to put it. So, there are two types of momentum. There's linear momentum and there's angular momentum. So, an object, outer space, I throw an object, no other force is acting on it. Technically, gravity is always acting on it, but it's very weak gravity, so almost a non-measurable force. It'll just pretty much keep going until some force stops it. Same speed that when I release it, it's got a speed. It'll keep up that speed. It'll keep going in that direction. You know, again, I'm a massive body, so I am applying gravity to it, but it's such a small amount of gravity that it will be unnoticeable for a while. Then there's also angular momentum, which is basically a spinning object. It'll go through the same amount of, the same angle, same number of degrees in the same amount of time, unless another force is acting on it. So I spin a top, well, I go into outer space, spin a top, so gravity's not affecting it. It'll keep spinning, 10 rotations per minute, or however fast it's going. It'll keep going until, same rate until another force acts on it. Yeah, we don't think about it as much, but that, Newton's first law applies to spinning bodies as well as bodies in just linear motion. And so, again, it's conservation of momentum. We just didn't call it momentum, we called it, inertia. Now then. So we go out into outer space. Well, gravity. We got gravity is a force acting on just about everything. Like I said, it's any two objects that have mass are exerting gravity on them. The amount of gravity they are exerting depends on the distance they are from each other. So sometimes it's almost negligible. Other times, like here on the Earth, it's obvious. So it's not that no force is acting on anything, it's just how negligible is the force that's acting on it when we're looking at this. So here on Earth, I have gravity acting on me, holding me down, so if I jump, it's going to pull me back down. I'm not going to just keep going up and up and up and up forever. So my inertia is not constant going up. My momentum changes because I've got a force acting on me. Newton's first law is upheld. Incidentally, Newton's second law, F equals ma, that basically defines what a force is. Newton did not write it as F equals ma, mass times acceleration. So basically, in order to accelerate a mass or changing its velocity somehow, you're applying a force to it. He actually wrote that as the change of a force equals the change in momentum. Now, they're the same things, basically. Momentum is mass times velocity. Acceleration is velocity divided by time. So momentum divided by time is mass times velocity divided by time, which is the same as mass times acceleration. So it's the same thing, but again, Newton originally wrote his second law in terms of changing momentum, which allows us to do all the stuff we did at college level that we didn't do at high school level because we had the proper definition going on. So I'm on the Earth. We turn off the Earth's gravity. Um, okay. That's going to cause nothing really to happen because we've stopped a force that's been acting on us. We haven't created a new force. So I'm just going to sit here. We're ignoring stuff like the rotation of the Earth and the fact the Earth is moving around the sun. So in reality, I'm going to continue to move as the Earth has been carrying me. So at the equator, the Earth moves, rotating a little over 1,000 miles an hour. Where I'm at 40 degrees latitude, we're going a little over half that. So I'm right now moving about 500 miles per hour that direction. Turn off the Earth's gravity. I'm going to continue going that direction. The Earth is going to continue spinning that way. So I'm not going to notice it as much for a while. Now I'm going to move in a straight line instead of going the curved path I am currently going as the Earth carries me around. So eventually, yeah, I'll start to notice that I'm no longer standing on the ground because the Earth is still doing its thing and I am going in a straight line as opposed to going in a curved line. One difference now, like I said, the Earth is moving around the sun, depending on where you are at. So, daytime, I am actually moving in the opposite direction that the Earth is moving. So, I am moving this direction. The Earth is spinning this direction, but as the Earth goes around the sun, it's actually going that direction. Now, that said, I am also traveling that direction with the sun, so I have that also going with me. So, again, it's not that the Earth is going to suddenly just go out from under me. It's my actual speed is just the speed the Earth is going that direction minus the speed I'm going this direction based on the Earth's rotation. So I might notice some difference there. If it was nighttime, then I would be moving the same direction as the sun. You know, my rotation, not the sun, the Earth. My rotation with the Earth would be giving the same direction as my movement with the revolution of the Earth around the sun. So it would be less noticeable, less soon. But that's a tangent. The main thing is the Earth starts spinning. It'll be a while before I notice I'm not standing on the ground, simply because the Earth is so large and it's moving with me. Now, my house is attached to the Earth, so it's rotating with the Earth as it rotates. My inertia is going to want me to go straight, not rotate with the Earth. So I might notice over time, wait a second, my wall's at an angle. So I'm probably going to hit somewhere up there, high up on the wall or up in the corner where it meets the ceiling. Because again, everything's inertia is still working, so it's going to keep rotating. I'm going to try to move straight instead of, the only reason I'm rotating is because a force is acting on me. Turn off the Earth's gravity, that force is gone. I'm going to want to go in a straight line. So we go out into outer space, though, and now things get more noticeable. So go on to space station. Now the weird thing is, a lot of these videos, the ones they were trying to debunk that we've been in space, people are standing on the ground, which is very unlikely. The ones from NASA, that's the point I wanted to make earlier, yes. One of the things the people who are trying to debunk we've been in space kept saying, this is on the space station's and website. You can look it up yourself. So I tried to find out. International Space Station official website, couldn't find anything. I went to NASA to find my videos that I watched. And so, is that what they were referring to, or were they just making stuff up? Because, like I said, the International Space Station apparently doesn't have its own website, not that I could find. NASA has several videos made, on their website, which were made on the space station. So, why didn't they say you could find this on NASA's website? Why did they say the space station's website? They might have meant, NASA's section of the website dedicated to the space station. They might have meant that, but they didn't say that. That's got me questioning these people trying to debunk it all. Anyway, so I'm on the space station though, and again, these debunked ones, videos. Let's debunk the space station. Let's debunk that we've been in space. They got a lot of people standing on the ground, flat-footed. Possible. I mean, you would have to brace yourself and get to the point where you're not moving and then you're standing there. The NASA ones I looked up, there are people more a little off balance. I mean, they still want to stay in contact with the ground as much as possible, sort of. They aren't just floating around like they show on TV and movies all the time. But they are acknowledging to some extent these people are not just, I'm on the ground. There is a little unsteadiness to them because any move they make, they are putting force on the ground or on the wall around them or whatever, and that's creating a force, and so that's going to push them away. There is gravity because they're still within a massive object, but that gravity is very negligible compared to the gravity we're feeling here down on Earth. So that's something you got to consider. And so, like I said, the ones, we're going to debunk the space station. Gravity seems to be a lot stronger on the space station in their videos than when you actually go to NASA's site, and you can see people are a little more floaty. Now that said, we get to Newton's third law. For every action, there's an equal and opposite reaction. So I push on something that's pushing back. See, we don't notice this much. I push on this. Technically, it pushed back on me, but it all went that direction. Why? Because I'm braced more. I've got friction holding me down. I've got leverage. Whereas that didn't. It was smaller. It was a lot easier for me to move. I was creating more force into it. As opposed to, say, pushing a car. I have pushed a car before. I can do that if I have traction. There are other times I've tried to push a car without traction and got nowhere. So the whole, third law, it seems like a weird one, but it does come into play sometimes. And so when you're on the space station, it's going to come into play more. One video, guy showing how do we eat in space. And most of their food is dehydrated because water weighs stuff and they want to keep down on the weight. And so they got to take their pouch of dehydrated food and they plug it into a thing which will fill it with warm water and rehydrate it. Now when he pushes it in, he's pushing against the wall. He has no gravity. He doesn't have the same gravity I have holding me down. He doesn't have the same friction, the same gravity because most of my friction is created by the fact that gravity's pulling me down. So when he pushes against this, his body should move back a little. Unless he's braced himself against something. It didn't seem to. And the thing is, where the camera angle, I couldn't really see, is he braced or not? So I started watching for that in videos. People pushing buttons, touching stuff. Are they affecting themselves as much as they are affecting the object they're trying to manipulate? And are they braced when they do this? Or is it pushing back at them noticeably? Unfortunately, I couldn't find many good videos where you could really tell if they were braced when they were doing stuff like that. Most of it was a close up, so you can't see. My legs are down here, and I've got one foot against this, so it's holding me in place. Or you can't really tell that much. That would be something to look for if I was actually trying to debunk have we been in space or not. But like I said, that wasn't the purpose of my doing this. So back to the hair, though. Like I said, the fake ones, the ones in the original video I saw, yes, it really looked like these women's hair was lacquered in place. It was like very stiff. She turns her head, it turns with her, and all that. Hair's interesting. When we get into inertia, hair is very fluid, let's say. Instead of looking at a strand of hair as an object, you got to look at it as several objects linked together. Like, think of it like a chain. You've got a bunch of links. Each one's going to act on its own, but they're connected, so they're going to pull on each other too. And so if I had a chain and I was waving it around in space, the link at the very end would have the most inertia, but it's still going to get jerked back by the others. It'll wave around, and hair would do the same thing. So, no, it wouldn't be all lacquered in place. It wouldn't be sitting straight up. It would be flowing and going around. So I did try to find videos from NASA's site with women with long hair. I only saw 2 women in the videos I saw. Didn't watch a whole bunch. One of them had maybe shorter length. It was always standing up. It looked like it might have been hairsprayed in place, but it wasn't lacquered in place. So when she moved her head, it did shake around a little bit. And again, it was short. It's I think in terms of my hair, obviously it's short now. If you've seen any of my videos when I had longer hair, my hair doesn't grow in long; it grows in thick. And so it's still sort of matted together and sort of interwoven. So if I shake my head, you don't see my hair wave around even when it's long, because it sort of moves together. And so this woman, like I said, looked like her hair was hairsprayed. Although, why wasn't staying down if it was hairsprayed? The other woman had longer hair, but she tended to wear it tied up. So she'd have it like a little bun of some sort, then she'd have these strands going out. And they were a little stiff, but they did sort of move independently of each other too. So it was hard to tell. I would understand why a woman in space would tie her hair back instead of just letting it flow free, because again, inertia, it's going to be going all over the place. Every time she moves, it's going to want to continue to move the same direction it was going. And so it's going to be in her face half the time. So I can understand why a woman in space would tie her hair up. So that part makes sense. But so looking at the hair, it was hard to tell, how is inertia working on these hair? Now, other objects floating around, there were times that thing seemed to speed up. No one was touching it. It seemed to speed up. That thing seemed to start spinning faster for some reason. Is that the effect of some guy with his video camera making a thing in his basement, and he just doesn't know the laws of inertia, and so therefore he had the stuff start to move randomly? Or are there other forces on the space station we aren't thinking about? Like air. You are in a sealed container, you're recycling your air, it's blowing around. So an object floats past an air vent, yes, it might start to spin up faster, it might change direction. So in order to rule that out, I would need like a schematic of the space station's air duct system. And then I'd have to watch videos and say, okay, this is happening on this place in the station, so we expect forces to be coming from these directions. So yes, something might speed up here or something. So you would have to go through all that. You can't just point at this and say, something sped up, therefore it's a fake video. So that is it. Basically, people when they are questioning things, when they're making fake videos, that's one thing I was going to mention. Because that's the Kennedy experiment. It was a show from the '90s, hidden camera show. Jamie Kennedy was the host. And so we had one. We got these temporary employees at a place. We're working on an anti-gravity experiment or device. Only it's not working as well, but our investors are coming in. So what we want you to do, we took this room, we bolted everything to the ceiling. We want you to put on the anti-gravity suit and pretend like you're walking on the ceiling. And we had a closed circuit TV, so they won't actually be able to see you. It's turned upside down, of course, so it looks like everything's. And so that was it. They would have 3 or 4 people they would do this with, and then they'd show the clips. And all the people doing it, they were like walk around with their arms in the air. It's like, here, I'm walking on the ceiling, and well, your arms aren't trying to fall down. Your arms are still going to be at your side unless you hold them up. Because forces, you know, my natural inclination is to hold my arms at my side. And yes, if I go completely limp, if someone gives me a tranquilizer, my arms will go over my head if I'm hanging upside down. But if I am just got anti-grav shoes on or something, where hanging from the jungle gym or whatever, I can cross my arms. I can still hold my arms at my side. I'm not automatically going to go like this. It's really, what do I want to do with my arms? I'm still in control of them. That's a force. That is not inertia forcing my arms to go towards the ground. That's just another force opposing gravity, me holding my arms where they are. For another reason, this is completely off subject, all the people spoke in a deeper voice because anti-gravity somehow changes your voice, question mark. Voice, it's going to deal with how thick the air is and qualities of the air. For gravity to change your voice lighter or deeper, it would have to be like strong enough to like compress the atmosphere or weak enough to let the atmosphere thin out. And then it might affect how your voice sounds. You're not going to suddenly talk like this just because you're in an anti-gravity environment. Unless someone changes the atmosphere somehow. And so that again goes back to people's belief, how does gravity work? How does inertia work? Well, it doesn't quite work the same way you think it does. Abbott and Costello Go to Mars did the same thing. They went into outer space, on the rocket ship. For some reason, they started speaking deeper. Yeah, that's if Abbott and Costello do it, it's got to be questionable science. So that is it mostly. Like I said, I just wanted to talk about the difference between gravity and inertia. I didn't really do that as much as I did, talking about these videos I saw. But it is the difference between gravity and inertia, which really makes me wonder, the people making these videos, do they really understand what they're talking about? I will point out also on the NASA site, they did have 2 videos dedicated to Newton's first 2 laws. Shot on the Space Center. And they got some stuff wrong. Where it wasn't so much wrong as they could have phrased stuff better. So their demonstrations, yes, this is a demonstration of the first law, this is a demonstration of the second law, but the way they phrased things was a little questionable. So even NASA doesn't fully have it correct. And it's not that they had it, the principle is wrong, they just didn't phrase it as well as they could have to transmit what they wanted to say. That is it. Gravity is not inertia. It does affect inertia because it is a force, but inertia is not gravity. Turning off gravity doesn't automatically make things fly away. Inertia will still have them continue as they would. Have a nice day.